Hello, clever engineers! Today, we're going to talk about how to diagnose and repair an HVAC unit. Before we get started, I want to explain that I'm a professional system engineer. I'm not an HVAC tech, I'm not an HVAC expert, and I've never diagnosed or repaired an HVAC unit in my life. I don't know the industry standard way to diagnose this, and that's not the point of this video. So if you're an HVAC expert watching this, please remember that when you make your comments. The point of both this video and this channel is to show how you can use clever engineering to solve problems. I bring this up because I've received a number of comments in some of my videos where people with decades of experience tell me that my out-of-the-box solutions are somehow wrong or won't work because they are different from the solutions that experienced people have used for decades. Let me ask you this. What kind of phone did you use decades ago? What kind of computer or TV? If there's a better way, or even another way to achieve a great result, why would you want to rely on an outdated method that is only dictated by experience? Tell BlackBerry, Kodak, and Radio Shack that they can continue to lean on experience. I also pointed out in another of my videos that at the beginning of my career, I knew the solution another engineer was proposing was wrong. I told this to him as well as to management and explained why. His response, with no explanation attached, was that he had over 20 years of experience while I had only 2. The company ended up doing it his way. It didn't work, and they had to redo it my way, which worked. A few weeks later, he was no longer with the company. If you still have any doubts that my approach is effective, keep watching the video, and please like and subscribe. So with all that said, let's get into it. So we have a problem with an HVAC unit not cooling. Now we can hear the compressor. So we need to figure out what is going on. Of course, it could be thermostat. It could be the HVAC unit itself. Could be a power supply problem. But just like with all of my other videos, when we talk about system engineering and we talk about risk analysis, we have to look at what is and isn't likely. So I think we can virtually eliminate a few things right off the bat. So one of those would be an electrical problem. If there was an electrical problem, we would not be hearing the compressor. And that is pretty much something that we can avoid having to even waste time on checking. Now, here is what we know. We know that we have good power going to both the thermostat and to the HVAC unit itself because the thermostat signals the compressor to turn on. We hear the compressor turning on, but we do not actually feel any cold air. There's no movement from the fan. However, most thermostats, including old ones, they have a separate fan mode. So I don't remember what wire does what. I installed this a long time ago, and while I'm not an HVAC specialist, I'm going to use some logic as an engineer, a little bit of deductive reasoning here, and we are going to see if we can get the thermostat to signal the fan to turn on. Now, there still may be an issue with the thermostat, but we would at least know where to start looking. So if we go into the settings here, say fan schedule, let's just always have the fan from 12 a.m. to 12 a.m. and set. So now we have the fan schedule enabled. However, while that should mean the fan should turn on right now, absolutely nothing is happening. So once again, we have a really solid jumping off point. There is a chance it is the thermostat, but I would say there's a pretty small chance of that only because thermostat is signaling the compressor, but not the fan. There's also a chance that it is the board where the controller of the HVAC unit itself is not signaling the fan, or possibly the relay is not clicking because it has gone bad. And of course, there is a great possibility that it is the fan itself. So let's do a little bit more diagnostic work and see what happens. So here we just have the front cover of the HVAC unit open, and we're going to do a little bit of explore. First thing I see that I'm going to look at are these fault codes, because it says that the LED might be doing something if there is a fault. So we have the LED right in this little glass, and in fact it is flashing slowly. So right here it says slow flash over under voltage shutdown. Now that could be one of several things. Again, I don't think it's the power supply just because of the compressor, but there may be an issue with the board. At this point, from what I'm seeing, it's fairly unlikely to be the thermostat. What also could be going on is that there may be a short, or maybe the fan is clogged with dust and is basically causing an error when the fan tries to spin, and that affects the voltage of the entire system. Because if there is a short or a problem with the fan or excessive resistance, that could definitely be putting too much of a load on it, and the system just cannot provide the required power to turn the fan. So this is also some pretty useful information here, again, just from looking at a couple of things over a couple of minutes. So let's continue. I just flipped down this panel right here, and by the way, the compressor is cycling on and off. I'm going to do a couple of quick tests on this control board. But before I do that, I'm actually going to turn off the main circuit breaker, not this one here, but the one that's actually on the circuit breaker box, just because it looks really dingy and dirty here. And I'm going to give this a quick clean, and also just undo all of the contacts and put them back in, because there is always a chance that something just got oxidized in the contacts. I mean, that's all it is. That would be wonderful. But again, let's just try the most obvious and simple things first. So stand by. All right, so I did a quick little clean, and also reseated some of these connectors here, and turned the breaker back on. Now I also put a flashlight, and one thing, now this is not necessarily the problem, but I do see that these resistors look like they've definitely gotten a little hotter than they should, because we should not be seeing those burn marks on the board. Now we also do see two relays on the board, so very likely one of those is going to be triggering the fan. So again, just not having any experience with this type of system, but using logic and reasoning, we are going to continue our diagnosis. Now, I did turn the breaker back on, and we do not seem to have any fan activity, so it does not look like it was an oxidized connector. I mean, frankly, that would have just been too easy. But let's continue. All right, so I just backed out the screws on this panel here. So let us see together what is behind here. I am guessing, because I actually remember from when I changed the filters, the compressor is on the bottom. So I believe the fan is going to be up here. Let's see. Okay. And whoa, it's a big guy, but there it is. So we are going to try to turn it by hand. So I turned this switch off, and by the way, if you're not 100% sure about where your electrical supply is, I know just from looking at everything here that it is all on the right side of this top area for the high voltage supply that would be controlled by this switch. But if you're not sure, by all means, go ahead, turn off the breaker in your main box, because better safe than sorry. So we're first going to try to turn the fan over by hand, And if it spins easily, which means that there's no issue with anything being stuck in it or with the bearings worn out, we're going to start testing some voltages. So we're going to look at that start capacitor, and looks like some connectors to the actual fan itself. So let's continue. All right, so we were able to spin the fan over quite easily. So we know that there's nothing stuck in the fan, and we know that the bearings are not seized. So we are going to try to turn this back on and see if we have any voltage to the start capacitor. Now, I know, of course, this is AC because I saw how the wires go in from the top, and these go from a high voltage, looks like it's a contactor or a high voltage relay, but either way, I'm going to switch this to AC volts. And we are going to find out together what happens when I turn this breaker back on. So let us see. Now, so it looks like we have some good AC going to the contactor, or rather the startup capacitor. So we can, from this, pretty much eliminate anything in this box. So we, I think, are pretty close to a diagnosis. So one thing that I noticed here is this connector right here. So you can see there is a high, medium, and low position, and it is in the medium position. Now, fan, you know, it's never sped up or slowed down when it works, so clearly it's only wired to work at one speed. But having said that, if only the medium mode of the fan is broken and it's not too loud in the high mode, we may be able to get away with fixing it like that. It's a little bit of wishful thinking, but I want to see what actually is coming out of this as far as voltage, just to make sure that there's something there before we even try anything else. So let's do that next. All right, so we're ready to find out together what's going to happen. Now, why did I plug the meter into here and here? Well, the reason is we know that our high voltage AC comes out of here. So we know one leg of it goes to that position that was high, medium, and low. We know the other leg goes to this part of the start capacitor. So again, without going into the schematics, the wiring diagrams, just using a little bit of deductive reasoning and maybe a little bit of clever engineering, we are going to turn this back on and see if we have some voltage on the meter. So this is just residual, so that doesn't mean anything. Obviously 0.2 volts is not anything to make a fan spin. So anyway, let's turn this back on and see what happens. Oh, so we have, this is interesting. Okay, so we have 207 volts. It looks like it just took a little bit for that contactor to kick in. So once again, we know that we have voltage going into both the top part of the start capacitor and to that high, medium, low switch. So now, before we do any more digging on the start capacitor, I'm just going to try something really obvious. I am going to move this connector to the high position just to see if anything changes. Of course, we're going to power this off first because I do not want to get hit by 200 volts for obvious reasons. So let's try that. All right, so unfortunately, moving the wire into the other positions did not do anything. But one thing I did notice, so I have the meter back on the capacitor here. So here we are at 183 volts, where when we actually measured the wire from this leg as well as from the black wire there, we were at over 200 volts. So before we conclude that it is definitely the fan, I do want to do a little bit more digging into this little capacitor here. So let's continue. Okay, so you can probably see it is dark now, and the reason for that is because I needed to get a new battery for my capacitance and ESR meter. And of course you can do this test with a multimeter in capacitance mode, but this particular meter does way more because it tests ESR, which is very, very important to determine the health of a capacitor. That's how we're going to find out not just what the capacitance is, but if it is good or not. So we're going to find out together, and let's see what happens. Okay, open circuit or low capacitance. So that actually tells us that looks like this capacitor is bad, and if that is the only thing that's bad, we've really dodged a bullet, because that is around $10–11, where this fan is probably a couple of $100. So let us replace the capacitor. We'll get it ordered, and we will pick this back up very soon. Alright, so we have our new capacitor, and let's just make sure. We will find out together how this one looks. Oh, look at that. That is absolute perfection. So we are going to put this back. Of course, there is a tiny minuscule chance that the blower is also bad, but I have a feeling that it is absolutely fine, and it was just the capacitor. So put that back, we'll test everything, and then changed this filter about a year ago. It's actually way overdue, so if the blower works again, I'm just going to change out that filter. Alright, so we have our new capacitor all hooked up, and before we do our final test here, where we're going to have the main panel breaker back on, just need to energize this switch here, but I just wanted to point out something about the capacitor itself. So when I was looking for the replacement, I saw that there are a whole bunch of different types of these capacitors. And what's much more relevant is clearly a different brand. It's even slightly a different size. But the most important things are the shape, so it fits into the bracket properly, and of course the value. Now, this is a 5 microfarad capacitor with 5% tolerance. This is a 5 microfarad capacitor with 6% tolerance, and so when it was tested, it came right up at 5 microfarads, so that's perfect. Now, we also have to make sure that the voltage rating is appropriate. So this one here, 370 volts AC. This one here is 370 or 440 volts AC. So clearly that rating is all good. So the brand is, again, far less important than the actual values. So let's give it a try. Alright, so we have the switch on, and oh, look at that. We put the flashlight in there so you can see that we're in business here. The problem is solved, the diagnostic and repair is complete. Again, I want to reiterate, I have never repaired an HVAC unit before. I've never diagnosed one before. Just did a little bit of clever engineering and knowledge of basic electricity to make this all happen. And obviously not counting the shipping time for the parts, this whole thing start to finish took around 20 minutes. So, and this was around $10 for the capacitor there. So basically, if you do a service call, I'm sure that they'll have every type of capacitor in the van, you know, the HVAC company, but in addition to scheduling it, making sure you're around, you're also going to have to pay very likely hundreds of dollars, and that's something that we were able to completely avoid. So that is it for now. Clever Engineer out.